So we're going to use the intermediate value theorem to prove that x cubed plus 3x equals 10 has at least one solution on the closed interval 0, 2. So let's look at this piece as being f of x. So we want to show that f of x has to equal 10 somewhere in this interval. Well, let's see what's happening on our endpoints. Well, f of 0 is 0 cubed plus 3 times 0, which is 0. F of 2 is 2 cubed plus 3 times 2. What is that? 8 plus 6, which is 14. So we know that this polynomial function is continuous. So it is continuous because it's a polynomial. And we have to state that's why we know it's continuous. We know that f of 0 is 0. We know that f of 2 is 14. So therefore, there has to be some x value in between 0 and 2 where its y value has to come somewhere between 0 and 14. So by the intermediate value theorem, there exists some c value in the element in the interval 0, 2 such that f of c equals 10, because 10 is in between 0 and 14, so therefore there has to be some x value in between this open interval such that f of c equals 10. And let me not forget that it has to be continuous on the closed interval. So my function is a polynomial function, so therefore it is continuous everywhere on this closed interval. We saw that on our two end values, f of 0 is 0, f of 2 equals 14. So that means somewhere from 0 to 2, our graph is going up from 0 to 14. Well, if I have a continuous graph that's going all the way from 0 all the way up to 14, somewhere from 0 to 14, there had to exist a c value in that interval from 0 to 2 such that f of c equals 10. And that is guaranteed by the intermediate value theorem. So notice I had to state all three parts, that it's continuous. I had to check that my two end values covered the range of what I'm looking for, and then I stated that I'm using the intermediate value theorem to prove that. So I would like for you all to see if you can set up that same kind of proof, checking all of these parts of the intermediate value theorem to prove that this polynomial equation has at least two solutions. So think about that. It has to have at least two solutions. So that might throw you for a loop, but we'll talk about that the next time we meet.